If a new tool suddenly made the most tedious, mind-numbing part of your job 50% faster, what would you actually do with that extra time?
Oh, that is the million-dollar question, isn't it?
I mean, I want you to really think about that for a second. Let's say it's 2 p.m. on a Tuesday, right?
Mhm.
Your major reports are miraculously done. Your inbox is totally sorted.
A rare feeling.
Very rare.
Okay.
So would you clock out? Would you grab a nice coffee, head to a park, and just, enjoy the sunshine?
I think we both know the answer to that.
Exactly. Knowing human nature, and more importantly, knowing corporate expectations, would you somehow just end up doing twice as much work?
It's the ultimate modern trap. We spend centuries inventing these brilliant machines to save us time. The washing machine, the personal computer, the smartphone.
Right.
And somehow, paradoxically, we all end up feeling busier and more exhausted than ever before.
Well, welcome to the Deep Dive. We are thrilled you're here with us today, whether you're commuting, walking the dog, or actively hiding from your boss.
Hopefully hiding successfully.
Because the research on the desk today answers that exact question. And not just for your personal Tuesday afternoon schedule, but on a massive, global, macroeconomic scale.
Yeah, the numbers are wild.
We're looking at some genuinely jarring statistics from the first quarter of 2026. The tech world is officially calling this the Great Cognitive Rotation.
It sounds like a sci-fi movie title.
It really does. Picture this. Over a very short period, the technology sector lost about 55,000 established jobs.
Which, if you were reading the news, generated endless, terrifying headlines. I mean, it felt like the sky was falling.
The doom and gloom was inescapable. But hold on, because here's the twist. Simultaneously, during that exact same period, the global economy spawned 1.3 million new AI-enabled roles.
It's a staggering contrast.
Let me just pause and do the quick mental math on that. That is a ratio of roughly 24 new roles created for every single job that was lost.
That's right.
It's like a weird episode of a sci-fi show where every time you zap a digital alien, 24 more instantly beam into the room. We're looking at a system that is multiplying work, not subtracting it.
And unpacking that bizarre multiplication is precisely the mission of our deep dive today.
I am so ready for this.
We need to figure out how making thinking, or at least, the computational equivalent of human reasoning, drastically cheaper, hasn't actually eliminated the need for human labor. It has multiplied it.
It's totally counterintuitive.
It is. And to understand the mechanics of why this is happening to your career right now, we are going to connect some seemingly totally unrelated dots.
Okay, lay it out for us.
We're going to explore the economics of 19th century coal. We're going to look at the very real psychological grief of skill loss. And we are going to slam face first into the hard physical limitations of the global power grid.
Welcome to the Deep Dive. I'm Satosha.
And I'm Satoshi.
I love a good historical detour. So to understand the cutting-edge artificial intelligence job market of 2026, we first have to jump into our DeLorean and travel back in time to Victorian England. Grab your top hats, folks.
A top hat is strictly optional, but a basic grasp of industrial economic history is pretty mandatory here. We have to start with a concept called the Jevons Paradox.
Okay, Jevons Paradox.
Yeah, this goes back to an English economist named William Stanley Jevons. He published a highly influential book in 1865 called The Coal Question.
The Coal Question. Wow. Sounds like an absolute thriller of a beach read.
Yeah.
I'm assuming it didn't top the bestseller lists next to Charles Dickens.
Well, it was actually incredibly controversial among policymakers at the time. Jevons was observing the Industrial Revolution unfolding in real time.
Right.
Specifically, he was obsessing over the steam engine. You had Thomas Newcomen's original incredibly clunky steam engine, which basically guzzled mountains of coal just to pump water out of flooded mines.
Right, the early tech.
Yeah,
Super inefficient.
exactly. It was hugely inefficient. Then James Watt comes along and completely redesigns it, making it vastly more fuel efficient.
Okay, let me stop you there, because common sense dictates a very specific outcome here.
Let's hear it.
The engine is now more efficient. It uses way less coal to do the same hour of work. Therefore, the country of Britain is going to use less coal overall, right? The national coal reserves are safe.
That was the prevailing logical assumption of the British government at the time. But Jevons noticed the exact opposite was happening in the real world.
Wait, really?
Yeah. When Watt made the steam engine more efficient, national coal consumption absolutely skyrocketed.
Wait, why? If it uses less fuel, how does consumption go up? I mean, the map doesn't seem to work.
Because the efficiency didn't just save coal, it made steam power cheap enough to be used for things that were previously financially impossible.
Oh, I see.
Suddenly, the steam engine wasn't just pumping water out of mines. It was powering massive textile mills. It was driving locomotives across the entire country.
So it opened up completely new use cases.
Exactly. It was spawning entirely new manufacturing sectors that no one had even dreamed of a decade prior. Cheap power made new industries profitable, and therefore, the total aggregate consumption of coal exploded.
Ah. Okay, so bringing this back to the 21st century, coal is obviously no longer the primary resource driving the bleeding edge of the global economy.
Definitely not.
According to the research sitting in front of us, the new coal is cognition and code.
That is the core parallel. The marginal cost of human-like reasoning, data synthesis, and software creation is currently in a state of absolute collapse.
Collapse is a strong word.
I use the word collapse intentionally. The cost is dropping through the floor, driven by predictive AI, generative AI, and what we are now seeing with agentive AI.
And the research actually includes this incredibly intense mathematical formula to explain this phenomenon. It calls it the rebound effect.
Oh yes, the equation.
I'm looking at the equation right now. It has Greek letters. It has fractional exponents. I am absolutely not going to read this equation aloud because I don't want to trigger anyone's high school calculus trauma while they're driving.
Probably a safe bet.
But let me try to translate the mechanism into a real-world scenario. Tell me if this tracks.
Go for it. Let's hear the translation.
Imagine you're the CEO of a mid-sized company that builds custom mobile apps. Historically, let's say it takes your development team a full month and costs $100,000 to build a standard app.
Okay, 100 grand, standard baseline.
Right. Now, a new AI tool hits the market, and suddenly, writing the code for that app is twice as fast. You get a massive 50% efficiency gain.
Which is huge.
Huge. The cost to build the app drops to $50,000. Now, if the demand for apps is what economists call highly elastic, meaning the market has an almost infinite appetite for software as long as the price is low enough.
Which it is.
Exactly. Your company isn't just going to say, awesome, we saved 50 grand this month, let's send everyone home and go play golf.
No sensible CEO would ever do that. The income effect kicks in. You suddenly have disposable operational budget and freed up human capital.
Right. You take those savings, and instead of just building the one app for cheaper, you look at your backlog. You build 150% more apps.
You clear out the queue.
Yeah. You finally build that internal HR portal. You build an app for the corporate cafeteria menu. You build a highly complex app just to track your office ping pong tournament bracket.
A vital piece of corporate infrastructure.
Obviously. Because the increase in usage, the sheer volume of new apps you were suddenly inspired to build because it's so cheap, outpaces your initial efficiency gain.
Yep.
The total amount of human labor needed to manage, deploy, and monitor all these new projects actually goes up. Your company's demand for work rebounds past where it started. The research calls this a rebound of over 100%.
And that is the Jevons Paradox manifesting in the digital age. The efficiency induces a surge in demand that more than offsets the initial labor savings.
It makes total sense when you frame it like that.
And what's crucial to understand from the research is that this isn't just driven by a chatbot drafting a polite email or generating a little snippet of Python. It is driven by a fundamental shift to agentic orchestration.
Oh, this part blew my mind. The research refers to a practice called vibe coding.
Vibe coding, yes.
Which, honestly, sounds like something a DJ does at a tech conference in Miami at 2 a.m.
It does sound a bit informal.
But the mechanism behind it is incredible. The research defines vibe coding as the ability to just sit down, describe a complex application in natural language, like, hey, build me a secure web portal where our freelance writers can upload invoices, track their payment status in real time, and get automated end-of-year tax summaries.
A very specific prompt.
Yeah, and then an agentic AI system orchestrates the entire thing. It doesn't just write the text. It provisions the database, sets up the front-end user interface, establishes the security protocols, all in minutes instead of weeks.
It is a profound architectural shift. We are moving from deterministic scripting, which is the old way of coding, where a human developer had to manually type, if X happens, then execute Y for every single minute possibility.
Right, the tedious stuff.
Exactly. We are moving from that to autonomous, multi-step workflow execution. The cost of entry for building complex functional software has essentially dropped to near zero for anyone with a clear idea and decent natural language skills.
Okay, but I have to push back here.
Right.
I have to ask the completely obvious question that I'm sure everyone listening is screaming at their steering wheel right now.
Okay, bring it on.
If the AI is doing all the building, if the agentic AI is doing the vibe coding and setting up the databases and writing the security scripts, why do we need human hands on the keyboard at all? I mean, shouldn't the corporate demand for labor just vanish if the machine can orchestrate the whole project from a voice prompt?
It's the logical question to ask, and it brings us to what the research calls the scale effect.
The scale effect.
Right. To understand why human hands are still desperately required, we have to look past the hypothetical ping pong apps and look at what is actually happening inside the massive tech companies that have been making all those terrifying headlines for layoffs.
Okay, let's dissect those 55,000 lost tech jobs. The research looks at 171 global layoff events that happened by mid-March 2026.
The peak of the panic.
Yeah, this is the period everyone on social media is calling the jobpocalypse.
A very catchy term, but largely a myth, according to the actual data.
A total myth. The research clarifies this so well. Out of those 55,000 layoffs, only about 20% were explicitly attributed to AI by the companies themselves.
Just a fraction.
Right.
Yeah.
So what is actually driving the other 80% of people losing their jobs?
Yeah.
If it's not the robots, what is it?
It is a confluence of very traditional, very human, very boring macroeconomic factors. We are looking at a general macroeconomic cooling.
Okay.
We are looking at the delayed hangover from the massive, unprecedented overhiring that happened during the pandemic era.
Oh, the hiring spree.
Exactly. Remember, in 2021 and 2022, tech companies thought digital acceleration would continue at a hockey stick trajectory forever. They were hiring people just to prevent competitors from hiring them.
Just hoarding talent.
Yes. Add to that the aggressive Federal Reserve interest rate hikes that made borrowing capital expensive for the first time in over a decade.
So let me get this straight. AI is basically taking the blame for the Federal Reserve and terrible executive pandemic planning.
In many ways, yes. AI is acting as a very convenient, very futuristic scapegoat.
That is wild.
Think about the optics for a CEO on an earnings call. It sounds much better to tell Wall Street analysts, we are dynamically restructuring our workforce to lean into the AI revolution.
Instead of what?
Rather than admitting, we hired way too many people 3 years ago, we misjudged the market, and now we can't afford our payroll because interest rates are at 5%.
We are pivoting to the future, not we made a massive spreadsheet error in 2022. I completely get it.
It's a classic PR move.
But even if it's partly a corporate cover story, there is a real strategic shift happening in these companies, right? The research talks extensively about these strategic density plays.
Yes, and this is where we see the actual tangible impact of AI on corporate structure. Executives, the research specifically points to leaders like Mark Zuckerberg and Jack Dorsey are fundamentally rethinking the physical shape of their organizations.
And in what way?
They are focusing heavily on the talented individual as a force multiplier.
Okay, unpack force multiplier in this context. What does that actually look like in an office?
Before this cognitive rotation, if a company wanted to increase its software output, it had to hire a whole new department. You needed a department head, 3 senior developers, 5 junior developers to write the boilerplate code, and a QA tester to find the bugs.
A huge team.
Right. Now, by using AI to handle the baseline technical work, the repetitive coding, the basic bug hunting, the standard integrations leadership is moving toward much smaller, significantly higher skilled teams.
Okay, so less people, but more tech.
The operational theory is that one highly talented individual contributor, armed with an entire suite of AI agents, has the same output capacity as that entire mid-sized department from the previous decade.
The numbers on this leverage are staggering. The research cites Meta, where overall engineer output rose 30% throughout 2025.
Which is a massive jump.
But the real crazy stat is for the power users, the engineers who fully integrated these AI-native coding tools into their minute-by-minute daily workflows. Their productivity spiked by 80%.
An 80% spike is almost unheard of in traditional manufacturing or knowledge work.
Right. And then you look at Block, Jack Dorsey's company. Their leadership actually put a specific public dollar target on this strategy. They are targeting a gross profit per employee exceeding $2 million.
Which represents a 4 times increase in organizational economic density.
Oh, times.
And they are achieving that precisely by flattening the management hierarchy and leveraging these tools. They are intentionally trimming the fat, removing the middle management layers, whose only job was coordinating humans, and demanding that the remaining individual contributors punch massively above their weight class.
$2 million of gross profit generated by a single employee. That is just, it's hard to even wrap my head around the level of pressure and leverage that puts on one person.
It's a totally new paradigm for the worker.
You know, speaking of things that are incredibly valuable and efficient, we can't be more thankful that you all are as fascinated by these deep dives as we are.
We really appreciate it.
The key to this vote of confidence is the research we share on our website.
Exactly.
No login needed, new cookies, no trackers, and absolutely no advertisements. So please, if you want to dig deeper into the numbers and look at the actual breakdowns of these corporate density strategies we're talking about, check the link in the descriptions because today is a big one. Huge. So much data to look at.
Okay, pivoting back to reality here. We have companies actively flattening their teams, demanding extreme efficiency, and targeting massive output per individual.
Right.
If big tech is officially trimming the fat and demanding more from fewer people, who exactly is filling those 1.3 million new roles we talked about at the top of the show? Where are these jobs coming from if the biggest players are supposedly shrinking their headcount?
That is the core of the paradox, and it's where the story gets really interesting. To understand where the 1.3 million number comes from, we have to look closely at the methodology of the LinkedIn 2026 Davos report.
Okay, the Davos report.
Yes, which is titled, Building a Future of Work That Works. Right, because 1.3 million new jobs sounds like a utopian fantasy, but we need to know how they're actually counting a new job.
Exactly. LinkedIn tracks these AI-related jobs by monitoring the massive real-time data set of their user profiles. They look for distinct changes in job descriptions, new titles being minted, and newly added skills.
Okay.
So it is critical for anyone listening to note that a significant portion of these 1.3 million jobs are not entirely new humans entering the workforce in brand new, shiny office buildings.
So it's a lot of upskilling.
A massive amount of it. For example, if a mid-level marketing analyst realizes the industry is shifting under their feet, takes a few weekend courses, and adds generative AI workflows or prompt engineering for market research to their profile.
Then LinkedIn counts that.
Yes, LinkedIn's algorithm registers that as growth in the AI-enabled sector.
So the job didn't necessarily pop into existence from the ether. The fundamental nature of the existing job evolved.
Partially, yes. But the research is also clear that a huge swath of these roles are entirely new classifications. We are seeing the rise of what researchers are officially dubbing the new-collar era.
New collar. I like that. We had blue collar, white collar, and now new collar.
Exactly.
If I'm listening to this right now and I'm worried my data entry job is on the chopping block, what exactly defines a new collar worker?
It is a fundamental shift away from the traditional four-year university degree, acting as the ultimate, immovable gatekeeper of corporate employment.
Oh, that's interesting.
In the new-collar era, specific technical certifications, demonstrable portfolio skills, and the practical literacy to operate alongside complex AI systems are prioritized heavily over a generic bachelor's degree in a vaguely related field.
That is huge. The research projects that by 2030, 60% of new jobs will come from occupations that don't typically require a degree, as long as the person knows how to pilot the AI.
It's a democratizing force, in a way.
It's a phenomenon the research calls expertise leveling. The AI brings the elite textbook domain knowledge, let's say, complex data structuring or retrieving obscure legal precedents, and the human operator directs it, fact-checks it, and applies it to the specific, messy business context.
Which perfectly bridges us back to your earlier, very valid question. If the AI is doing the building, and it has all the textbook knowledge, why do we need so many humans?
Yes, please answer that.
The answer lies in two concepts: induced demand and something called the maintenance multiplier.
Okay, let's unpack the maintenance multiplier, because I think anyone who's ever owned a house or a car or even just a somewhat complicated bicycle instinctively understands this.
Maintenance is inevitable.
It really is, but it's wild to see the concept applied to software.
It is simply the reality of complex systems. When AI makes it astonishingly easy and cheap to generate code, as we discussed with vibe coding organizations, do exactly what you predicted earlier with the ping pong app.
They build everything.
They generate an absolute ocean of code. They are drowning in software sprawl.
Because it's practically free to make. A manager can just say, hey, AI, build me a dashboard for tracking office coffee consumption. Boom! Done in 4 minutes.
But the lifecycle costs of a software application do not magically vanish just because an AI generated the initial version in 3 minutes.
Right.
That coffee consumption dashboard now exists on the company's servers. It needs to be updated when the server operating system changes next month. It needs to be secured against new cybersecurity threats that didn't exist when it was written.
Oh, wow. Yeah.
It needs to be integrated when the company inexplicably switches its identity management provider. And eventually it breaks, or the AI hallucinates a weird dependency, or it creates a massive security vulnerability.
And the AI isn't going to proactively call the IT department to fix itself.
Precisely. The ease of creation leads to a massive, unprecedented sprawl of software, often in various states of disrepair or undocumented complexity.
It's like a nightmare for IT.
It creates a colossal, ongoing, highly technical backlog for human professionals who have to step in, audit the AI's messy work, untangle these deeply interconnected systems, and maintain the digital infrastructure. The Jevons Paradox guarantees that cheaper, faster creation leads to vastly higher maintenance volume.
This directly ties into what the research calls the someday pile. I absolutely love this concept because it's so deeply human.
It really is.
We all have a someday pile.
It is a universal experience. What stood out to you about the someday pile in a business context?
It's the idea that every single business, every entrepreneur, every local shop owner has a list of brilliant ideas that they've always wanted to execute someday.
But they never do.
Right, because previously the financial barrier was just too high. The research gives these great, highly specific examples, like an independent family-owned funeral home.
Okay.
For decades, they might have desperately wanted a highly customized customer relationship management system, a CRM, tailored exactly to the weird, deeply specific, sensitive workflows of their industry. But hiring a traditional dev agency in 2019 to build a custom CRM from scratch would cost them $80,000. It wasn't justifiable for a small business, so it went in the someday pile.
Or the research gives the example of an app specifically designed to track and analyze Rubik's Cube solving times with hyper-specific algorithmic metrics, a pure micro-niche.
Right. A talented developer would never spend 6 unpaid months building that, because the total addressable market is, what, 4,000 dedicated speed cubers? You'd never recoup your salary.
Yeah, it makes no economic sense.
But now,
Yeah.
today, the cost barrier to clear the someday pile is basically gone. You can vibe code the funeral home CRM over a weekend. You can generate the Rubik's Cube app in a single afternoon.
And what happens to the global economy when millions of businesses and individuals suddenly clear out their someday piles simultaneously?
Niche markets absolutely explode. You get this massive, incredibly long tail of hyper-specific software that actually solves real problems. But again, all of that new software requires human oversight, customer support, data privacy compliance, and eventual troubleshooting. You didn't eliminate the software developer. You just turned the developer from a bricklayer into a city planner trying to manage a million new, bizarrely shaped buildings that popped up overnight.
That is a very apt analogy. It is the architectural burden of cognitive abundance. We have infinite bricks, but we still need someone to make sure the city makes sense.
It reminds me of the AI workload creep phenomenon I mentioned. It's like buying a faster, higher capacity washing machine for your house.
Okay, how so?
When you upgrade your washing machine, you don't actually spend less total time doing laundry in your life. You just start washing your clothes twice as often because the machine made it easier.
That's true.
You wash your jeans after 1 wear instead of 3. You start washing your curtains.
The standard for what constitutes clean goes up because the physical cost of cleaning went down.
Exactly. And in the corporate world, middle managers are the ones constantly raising the standard.
Yeah.
Think about it. A manager sees that a data analyst used an AI tool to finish a massive, agonizing quarterly report 40% faster.
Right.
Does the manager say, wow, great job, take Thursday and Friday off to go fishing?
In my experience analyzing corporate behavior, absolutely not. They say, excellent work. Since that incredibly complex task only took you 2 days, I now want that report run weekly instead of quarterly.
Oh, brutal.
Oh, and I want you to cross-reference it with 3 new messy data sets we couldn't even attempt to analyze before.
Right. The cost of the task dropped, so the demand for the task's output skyrocketed. You don't get leisure time. You get more complex analyses, tighter deadlines, and endless projects pulled down from the boss's someday pile.
It never ends.
The total work time remains constant, but the velocity, the stress, and the complexity of the work go through the roof.
And while exploring the someday pile sounds like an exciting explosion of global innovation, executing these complex ideas safely within a highly regulated, remarkably messy corporate environment requires a very specific and currently very highly paid type of worker.
Okay, let's talk about the money.
Which brings us to a major bottleneck in the intelligence age.
If you are listening to this, looking for where the real life-changing money is being made in this 1.3 million job boom, this is it. Let's talk about the rise of the forward deployed engineer, or the FDE.
The growth statistics on this specific role are genuinely remarkable. According to the data, the FDE role has grown 42-fold over a very short period.
42-fold. That is insane.
And the mean salary for these positions is sitting well over $135,000, often much higher with equity.
Okay, so if the code is practically writing itself, why am I seeing salaries of $135,000 for these forward deployed engineers? What exactly are they doing that the AI can't just do for free?
To understand the massive value of the FDE, you have to understand something called the deployment gap.
The deployment gap.
Okay. The research highlights a staggering statistic from 2025. Approximately 65% of organizations that initiated major AI projects ended up completely abandoning them.
65%. That is a massive failure rate for a technology everyone is loudly claiming is pure magic. Why are they failing so spectacularly?
Because taking a pristine, incredibly smart, elegantly designed AI model like a GPT or a Claude and dropping it into a 50-year-old regional insurance company is like dropping a Ferrari engine into a horse-drawn carriage.
It shatters the carriage.
It completely shatters it. The corporate workflows inside these legacy companies are what the research calls black boxes. They're incredibly messy.
Right.
They rely on poorly documented legacy code, tribal knowledge that only exists in the head of a guy named Gary who retires next month, and deeply entrenched, deeply illogical human processes.
Oh, Gary.
These environments are simply not ready for clean, logical, digital automation.
I feel like we all know a Gary. Gary always ruins the pristine digital transformation.
Gary is a structural reality of enterprise business. You cannot code your way around Gary. So the forward deployed engineer is hired to bridge that gap.
So they are dealing with Gary.
The research describes them as a unique hybrid. They are part elite software engineer, part solutions architect, and part technical therapist. They are the ones jumping directly into the trenches of these complex, hostile customer environments.
The research calls them the civil engineers of the digital age, which I think is brilliant.
It's a great metaphor.
Think about it. A civil engineer doesn't actually spend their day hauling bags of concrete and pouring foundations by hand. They use heavy machinery as a tool.
Right.
But their actual job is solving the complex, structural, real-world problems, dealing with the uneven terrain, managing the local zoning laws, ensuring the bridge won't collapse when a hurricane hits.
That's spot on. The FDE uses AI as their heavy machinery. The AI writes the boilerplate code and pours the digital concrete, but the FDE solves the messy human and structural problems.
Like what, specifically?
Negotiating data governance, ensuring privacy compliance, figuring out how to integrate the shiny new AI with a legacy AS400 mainframe from 1998, and navigating the vicious internal corporate politics of getting the system approved by the legal department.
And this brings us to a couple of classic theoretical frameworks that explain why this bottleneck is so incredibly severe. The research brings up Amdahl's law.
Yes, Amdahl's law.
I want to try an analogy for this, and you tell me if I'm off base here.
Let's hear it.
Amdahl's law deals with the limits of speedup in any process. It states that the overall speedup of a task is strictly limited by its serial component.
Correct.
Meaning the parts of the task that absolutely cannot be parallelized or automated and must be done sequentially, one after another, by a human. So imagine I invent a magical quantum AI toaster.
A quantum toaster, I like it.
This toaster is a leap in technology. It can toast a piece of bread perfectly in 1 single millisecond. A 99.99% efficiency gain in the toasting phase.
A formidable invention. Breakfast is revolutionized.
Right. But to make a BLT sandwich, the toasting is only one part. I still have to manually untwist the little plastic tie on the bread bag. I have to pull out 2 slices.
Yep.
I have to carefully spread the mayonnaise so it covers the corners perfectly. I have to slice the tomato to the exact right thickness, wash the lettuce, and cook the bacon.
Those are your unautomatable serial components.
Exactly. The magical toaster is infinitely fast, but making the BLT still takes me 4 minutes because the human prep and assembly parts, the mayonnaise spreading now, completely dominate the project timeline.
That maps perfectly to software engineering in the AI era. The time it takes you to spread the mayonnaise becomes the bottleneck for the entire sandwich.
It really does.
Even if the actual coding part of building a new enterprise application is accelerated by 90% thanks to an AI agent, the human parts remain.
Gathering requirements, stuff like that.
Exactly. Gathering the actual business requirements from confused stakeholders, conducting the ethical and security reviews, testing for bizarre edge cases, and achieving strategic alignment across rival departments. Those are the slicing of the tomato and the spreading of the mayonnaise.
And the mayonnaise is always the bottleneck.
Always. As the automated portions of the work become effectively instantaneous and practically free, the relative value and the time cost of those human components actually increases dramatically.
So you need more people.
You need more human orchestrators, more FDEs, to manage all the prep and assembly required to keep the ultra-fast machines fed with useful work.
And the research layer is another classic rule on top of Van Daal's law, Brooks' law. This is the old software engineering adage from that famous book, The Mythical Man Month, right?
Yes, a classic text.
The principle that adding human resources to a software project that is already late will only make it later.
Precisely. And the fundamental reason Brooks' law exists is communication overhead. Every time you add a new person to a team, the number of communication channels grows exponentially.
Right.
Everyone has to be caught up to speed, everyone has to coordinate, meetings run longer, and the sheer friction of talking slows the project down.
So how does that apply when the new team members aren't chatty humans, but are AI agents?
It applies aggressively. While AI allows a single talented person to do more, we are now entering a phase where a single developer might be simultaneously managing a dozen different specialized AI agents.
A dozen. Wow.
One agent is writing front-end code, one is running back-end database queries, one is generating synthetic test data, another is checking for security flaws. These agents act like very eager but incredibly literal junior developers.
Oh, man. So we aren't replacing developers. We're just giving them a chaotic army of robot interns that they have to constantly babysit.
That is exactly what the research suggests. The communication overhead between the human manager and their agentic hive skyrockets.
I can only imagine.
You have to meticulously check their work. You have to correct their hallucinations before they break the build. You have to coordinate their outputs and ensure they aren't accidentally overwriting each other's code.
That sounds exhausting.
This massive complexity creates severe diseconomies of scale unless you hire a specific class of professional again, the FDE, whose entire job is to oversee and coordinate that hive.
And looking at the research, there are actually 4 highly specific tiers of skills required for these FDEs to babysit effectively. Tier 1 is foundations. That's non-negotiable stuff like Python, robotic process automation, and interacting with large language model APIs. You just need that baseline to even get in the door.
Then Tier 2 are the differentiators. This is where the value scales up significantly. Managing complexity and context using frameworks like LangChain or retrieval augmented generation, often called RGERCH pipelines.
Wait, explain how RAG actually works under the hood, because I hear that acronym thrown around constantly.
Think of it this way. Imagine your AI is an incredibly articulate genius who suffers from severe amnesia.
Okay, weird, but I'm with you.
It knows how to speak perfectly, but it knows absolutely nothing about your specific company. A RAG pipeline is like giving that amnesiac genius a massive, highly organized library of your company's private documents and hiring a hyperfast librarian.
Oh.
Before the AI is allowed to answer a user's question, the librarian, the retrieval part, sprints into the library, grabs the exact right manual, and hands it to the AI.
That makes perfect sense.
The AI then reads the manual and generates an answer based strictly on that text. It grounds the AI in reality. Building and maintaining that librarian system is a massive, highly paid skill.
I love that. Okay, then Tier 3, and this is marked as critical in the research, is human-centric, discovery, stakeholder management. This is the FDE sitting in a conference room with Gary, trying to document the black box process before he retires. It requires immense empathy and negotiation.
And finally, Tier 4 is emerging. Multimodal AI, fine-tuning custom models. This is the strategic layer of customizing the commodity intelligence for a specific competitive advantage in the marketplace.
It is a massive, incredibly demanding skill set. But you know what? Managing an army of AI interns, running RAG pipelines, and processing all that data takes an absolutely incredible amount of computational power, which leads us to a massive, physical, real-world constraint that you can't just code your way out of.
The physical infrastructure.
Yes. But before we jump into the deep end of the global energy grid, If you are getting value out of this show, we request you to check us out on fountain.fm. It's a value-for-value player where you actually get paid for listening without advertisements blocking your experience.
It's a great platform.
And of course, you can listen to us on Spotify, Apple Podcasts, or YouTube Music for free, or wherever you get your daily audio boost. As for videos, we still need to hit our goal of 1,000 subs on YouTube to start using the Mosaic AI video editor. Mosaic is truly a game changer for small creatives like us. It really is. We can feed it a YouTube link and it creates beautiful AI, cinematic captions, infographics, and a whole lot more we're still discovering in our capability tests.
It's pretty amazing tech.
All right, let's talk about the physical realm, the grid. Because all of these abstract digital thoughts require literal electricity.
They absolutely do. To frame this transition, the research highlights a brilliant framework developed by economists Darren S. Moglu and David Otter at MIT.
Okay, what's their take?
They make a critical distinction that completely changes how we should view technology's impact on labor. They separate technology into two distinct categories: automating technology and new task-creating technology.
Okay, break that down for me. What's the difference?
The MIT research points out a very dangerous market failure, which they call the automation ideology. Firm leadership often suffers from a cognitive bias where they perceive a greater immediate economic return from simply using machines to automate existing human expertise rather than using machines to invent entirely new tasks.
So using AI to just fire the 5 junior copywriters, instead of using AI to create a completely new kind of interactive, personalized marketing campaign that wasn't possible before.
Exactly. If AI is used purely for substitution, just swapping a machine for a human in a static, unchanging workflow, it might raise the average productivity of the firm on a spreadsheet, but it actively reduces the marginal productivity of the human worker.
It devalues them.
It reduces the unique additional value a human brings to the table. And historically, when that happens, the labor share of national income declines, wealth inequality widens, even as corporate profits soar. It is bad for workers, full stop.
But the alternative is the new task pathway.
Yes. New task-creating technologies are unambiguously pro-worker. These are innovations that open up entirely new uses for human labor that literally did not exist before the technology was invented.
The research gives some great historical examples of this to ground it, like MRI radiologists.
Perfect example.
That is a highly skilled, highly paid, vital medical profession that simply did not exist 80 years ago. The invention of the massive MRI machine didn't put doctors out of work. It created a new, hyper-specialized task of reading those specific magnetic resonance images.
The exact same logic applies to the AI era. We are seeing roles emerging like AI forensic analysts, whose entire highly paid job is to investigate the origins of machine errors or hallucinations in critical systems, like figuring out why a medical AI recommended the wrong dosage.
Wow, that's a cool job.
Or the prompt engineers and FTEs we just discussed. The MIT researchers argue that the 1.3 million jobs identified in the Davos report largely represent this new task pathway. AI is acting as a collaborator that extends human capability, enabling us to tackle vastly more sophisticated problems that we wouldn't have even attempted 10 years ago.
Great, and this is a massive, but tackling those massively sophisticated problems requires an unprecedented amount of physical infrastructure. This is where the Jevons Paradox leaves the theoretical software realm and starts impacting the physical earth we walk on. We're talking about the data center boom.
The sheer physical scale of this cannot be overstated. The collapse in the financial cost of cognitive labor for the end user is directly, physically, inversely proportional to the cost of powering those operations.
Meaning it takes a lot of juice.
Yes. While thinking is getting incredibly cheap for you and me on our laptops, the raw electricity required to power those massive server farms is skyrocketing.
The numbers in the research are wild. Last year alone, 600,000 new jobs were created specifically in data center operations.
600,000.
And these aren't all software guys sitting in ergonomic chairs. These are electricians maintaining high-voltage transmission lines. These are HVAC technicians building massive, complex liquid cooling systems because these servers run so hot they would melt themselves without them. These are hard-hat, steel-toe boot jobs.
Because the AI boom is, at its absolute core, a heavy industry boom. The research notes that in the U.S. alone, AI data centers are projected to drive 20% of total electricity demand by 2030.
That is 20% of the whole country's grid.
Think about that for a second. 1/5 of the nation's entire electrical grid dedicated solely to computational intelligence.
And here is where the macroeconomics and the engineering get incredibly tense. The research points out a massive divergence in global strategy, specifically highlighting a wildcard dynamic between the United States and China.
Yes, this is a critical point.
And as a reminder to the listeners, we are looking at this strictly through the lens of market dynamics and engineering efficiency, not politics.
Yes, it is vital we look at the raw engineering reality here. The United States tech giants are currently engaged in a massive historic capital expenditure cycle, investing hundreds of billions of dollars into building new data centers.
Because they need the power right now.
And because of the desperate urgency to get these online, many of these new facilities are reliant on natural gas power plants to meet the immediate massive power demands. These facilities are built with expected 30-year operational lifespans to make the math work.
Right. They are locking in the physical infrastructure based on the massive energy demands of current AI models. But the wild card the research introduces is the speed of innovation in algorithmic efficiency.
Efficiency is moving so fast.
The research specifically cites a Chinese AI model called DeepSeek. According to the engineering reports, DeepSeek was architected to run on anywhere from 10 to 40 times less energy than comparable U.S. frontier models.
Which, from a pure computer science perspective, is a staggering technical achievement in algorithmic efficiency.
40 times less energy. If that level of efficiency becomes the global standard, it creates a massive economic vulnerability for the U.S. infrastructure strategy. The research calls it the investment trap.
The investment trap, yes.
Think about it if you have just spent $1 trillion building massive gas-powered data centers that need constant, massive amounts of fuel, and suddenly the state-of-the-art models can run on a fraction of that power.
Perhaps easily run by local renewable microgrids or small modular nuclear reactors.
Exactly. Then those massive gas plants suddenly become economically unviable. They become what economists call stranded assets. They are useless.
It's a fascinating competitive race. The research suggests that if one region is locked into expensive, fossil fuel-heavy infrastructure, while a competitor develops systems that are exponentially lighter and cheaper to run, we could see a massive market correction.
It's a huge risk.
It could inadvertently force the fastest energy transition in human history, driven not by central planning or climate policy, but by pure, ruthless economic pain and competitive market pressure.
It's the Jevons Paradox again, but applied to the power grid. And I have an analogy for this efficiency trap. Tell me if you agree with this one.
Let's hear the analogy.
It's like highway expansion. In urban city planning, there's a well-known phenomenon. If a city has terrible gridlock traffic, the local government decides to widen the highway from 4 lanes to 10 lanes.
The logical intention being to alleviate the congestion by providing more capacity?
Exactly. But what actually happens in reality? For about 6 months, traffic is great. It flows beautifully.
Everyone is happy.
But then, because the drive into the city is now so fast and easy, people who used to take the commuter train decide to buy a car and drive. People move further away to the distant suburbs because the commute is suddenly manageable. Businesses build new office parks along the expanded route.
The dynamic changes.
And within 3 years, that massive 10-lane highway is completely gridlocked again. You didn't solve traffic. You just induced more driving.
Induced demand in urban planning is a perfect mirror for computational efficiency.
Right. So if an engineering breakthrough like DeepSeek makes an AI model 40 times more energy efficient, the global tech market will not respond by saying, great, let's use 40 times less electricity and save the planet.
Absolutely not.
They will respond by running 40 times more AI models. They will put a complex reasoning AI in every refrigerator, every traffic light, every child's toy. The efficiency breakthrough is just the catalyst for ubiquitous, inescapable adoption, turning AI into a cheap commodity we will constantly demand more of, pushing the grid right back to its absolute limit.
It is a relentless, inescapable cycle. And this brings us to a crucial, very human question. We've established today that the macroeconomic indicators are incredibly robust. 1.3 million new jobs, a massive boom in physical infrastructure and hard hat construction, endless new entrepreneurial niches being pulled from the someday pile.
By all the math on the spreadsheet, we shall be throwing a massive global parade.
Exactly. So if all these jobs and all this economic opportunity exist, why does the prevailing sentiment among the actual workforce feel so incredibly anxious?
It's palpable.
Why does everyone, maybe even you listening right now, feel like the ground is falling out from under them?
And that is the perfect pivot to our final area of the research, the psychology of the shift. Because human beings do not experience the economy as a macroeconomic chart or GDP statistic.
Yeah.
We experience it emotionally, in our daily lives.
We do.
And the research highlights a very real skill preparedness gap.
The LinkedIn data provides a fascinating contradictory paradox here. On one hand, job seekers are currently outpacing job openings at the highest level since the pandemic.
People want to move.
People are actively looking for movement. They want a new role. Yet simultaneously, nearly 80% of workers report feeling fundamentally unprepared to make a career move in the age of AI.
80%. That is a massive systemic crisis of confidence across the global workforce. And the research explains this using behavioral economic psychology, specifically a concept called loss aversion.
Loss aversion is the well-documented psychological principle that the pain of losing something is emotionally twice as powerful as the pleasure of gaining something of equal value.
Right. Losing a $20 bill out of your pocket ruins your whole afternoon, but finding a $20 bill on the sidewalk just gives you a brief little thrill for about 5 minutes.
Precisely. Now, apply that specific psychological dynamic to human capital and your deeply held professional identity.
Okay, that gets heavy.
The psychological pain of losing a skill that you spent 10 grueling years mastering, say, a specific type of deterministic coding or a specific manual method of data analysis deeply, viscerally outweighs the excitement of learning a new AI-augmented skill.
It hurts to lose that expertise.
The pain of the 55,000 lost jobs is acute, it is highly visible in the news, and it is deeply felt by the culture. The promise of the 1.3 million new jobs feels abstract, uncertain, and requires a daunting, exhausting personal pivot.
The research uses this brilliant analogy, the Manchester to Edinburgh commute.
It captures the dislocation perfectly.
Yeah, let me paint the picture. It explains that workers right now feel deeply dislocated. Imagine you've packed up your entire house in an industry you completely understood. You felt safe there.
Your comfort zone.
Now you're on a very long, very exhausting train ride to a completely new tech paradigm, a new city. It's raining, you're tired, and you have absolutely no idea if your old currency will even work when you get off at the station.
It's a scary feeling.
You are stuck commuting between an obsolete professional identity in one city and a new reality in a completely different city that you haven't learned how to navigate yet. You are watching the house you built your career in lose its value in real time, and you don't have the capital or the knowledge to buy into the new neighborhood yet. It's terrifying.
It is a profound structural transition, and it genuinely hurts. It requires a shedding of professional ego and an embrace of continuous vulnerable learning that is frankly exhausting for adults who are mid-career and just want stability.
But here is the ultimate beautiful irony that I noticed buried deep in the research. Only 3% of LinkedIn users currently list AI skills on their profiles.
3%. That's nothing.
So you'd think the panic is, oh my God, I need to learn how to code Python and build neural networks right now or I'm going to starve. But when they survey the massive companies, the ones actually doing the hiring for those 1.3 million jobs, 75% of them say that people skills are the real differentiators they're desperately looking for now.
Because the machines have entirely commoditized the math.
Yes. The machines are doing the math, generating the boilerplate code, parsing the massive data sets. The skills that companies are desperate for, the ones they will pay top dollar for, are critical thinking, adaptability, complex human collaboration, and stakeholder empathy.
Which AI does not have.
You do not need to be the smartest calculator in the room anymore. The computer has that covered for 3 cents an hour. You need to be the human who can sit in a room with Gary, understand his messy, illogical workflow, empathize with his genuine fear of change, and gently orchestrate the AI to solve his actual business problem without breaking the company culture. Empathy is the new bottleneck.
It is a fascinating reversion to our core nature. As the artificial becomes ubiquitous and cheap, the authentically human becomes the ultimate premium.
Which brings us to our final reflections. We've covered Victorian steam engines, magic quantum toasters, 10-lane gridlocked highways, and the profound psychology of career grief. Bring it all home for us. What is the big picture here?
If we summarize this great rotation, the core thesis we must take away is this. The intelligence age is not replacing the human mind. It is reallocating it.
Beautifully said.
We are living through a historic shift where basic cognition, pattern recognition, and rote data generation are becoming a cheap, universally abundant commodity. But because of the Jevons Paradox, that abundance absolutely does not mean the end of human work.
Just a new kind of work.
It means a massive, chaotic explosion in the complexity and volume of what we can attempt to build. And in that massively complex new world, The human premium emerges. The value of ethics, of nuanced judgment, of navigating highly ambiguous human relationships, and of listening hard to solve messy, real-world problems that becomes the most valuable resource on Earth.
Empathy over equations.
The machines will handle the execution, but humans are, and will remain, required to define the purpose, untangle the inevitable chaos, and care about the outcome. The Jevons Paradox guarantees that as thinking gets cheaper, we will only find larger, harder, and infinitely more complex things worth thinking about.
It's an incredible reframing of the panic. We aren't being replaced by the machine. We are being promoted to managers of a very strange, very fast, somewhat chaotic new workforce. And it all goes back to that question we started with at the very beginning of the deep dive. When the machine saves you time, you don't clock out early. You use that time to build something bigger, something that wasn't even possible yesterday. Once again, we request you to subscribe. And we want to invite you to comment and join our mission of collaborative intelligence, particularly if you have expertise in forward-deployed engineering, AI orchestration, or energy grid management. Keep searching. Keep the quest on Apsis. See you on next Deep Dive. I'm Satosha.
And I'm Satoshi.